So today I want to go over how to use the compound interest formula to solve problems relating to investments and compound interest. So as you should remember, compound interest occurs when interest is earned on your interest. So say for example, if you invest $1,000 at an interest rate of 10% per annum, so remember per annum means per year, each year your interest is, so the first year your interest is earned on your $1,000 that you invested. So you get 10% of $1,000, which is going to turn into $1,100. Now after the second year, we earn our 10% interest on our $1,100, not on our initial investment of $1,000 like we would with simple interest. So that's our difference between simple interest and compound interest. So the compound interest formula is slightly more complex than the simple interest formula. Okay, so we've got A equals P outside of 1 plus R all to the power of N. Remembering that A is the amount that the investment grows to. So this is different to the simple interest formula because the simple interest formula calculates the interest earned, whereas this formula, the compound interest formula, calculates the amount that the investment grows to. All right, so it basically calculates your final amount. P, same thing, is going to be the amount you start with. So of course we call that the principal as being the first amount. R again is the rate. Now we express our rate as a decimal. So in any question, you're going to be given your rate as a percentage. So you might be used to hearing about interest rates at 3% or 1.5%. Okay, when we're using them in the formula, we have to convert them to a decimal. So we obviously divide them by 100 to do that. Okay, and then when we put it to the power of N, that's the number of time periods that we're talking about. So you might be told an investment is growing over 3 years, so our time period would be 3. However, when we're given our time periods and our rate, our units must match. If they don't, we need to amend them to match. So I will show you an example a little bit later about how to actually go about that. All right. So as I mentioned, the compound interest formula calculates what the investment actually grows to. So if you want to calculate the interest earned, you need to use the interest is equal to the final amount minus the principal that you start with. Okay, so let's have a look at some examples. So I'll start off with a basic example. Okay, so how much interest will Jack earn if he invests $6,000 in a savings account that pays 5.5% interest compounded annually for 3 years? Okay, so it's just a matter of inputting our information into our formula. So our formula is going to be A for the amount that it grows to. Our principal, so our amount that we start with is $6,000. That's the amount invested. So 6,000 outside of 1 plus, now 5.5%, obviously we divide that by 100 and we get 0.055, and we put it to our power, so we're told that it's 3 years. So we just firstly double check before we write it in our formula. We firstly double check that our interest rate is calculated in the same unit as our time period. So we're told it's compounded annually, and it is for 3 years. So obviously annual means a year and 3 years. So that's a check. That is all good to go ahead. All right, so it's for 3 years. Now, I know it may be tempting to say, oh, well, that's just 1.055. And you're exactly right, 100%. But I would discourage you from simplifying that, because when the questions become more complex and we have to amend our rate to match the time periods, it's not going to work quite so well. All right, so I discourage you from simplifying that to be 1.055. Just leave it as a sum. Okay. So obviously we just plug that into our calculator and we end up with $7,045. $6,600.45. So as always, I'd encourage you to make sure that your answer is a reasonable answer. Okay, $6,000 after 3 years growing to $7,045.45 is definitely a reasonable answer. Had you got an answer like 3 million, I might be double checking what actually went into the calculator, because as you can imagine, that's not really a reasonable investment after 3 years. If it was, everyone would be investing $6,000. Just on another note, when we are working with money, if we are not given a specific unit to round to, we always round to 2 decimal places, because of course that is the nearest cent and that is how we use money. Okay, so I want to show you another example where we will need to amend the interest rate to match the time periods. So we're asked to calculate the final investment amount if the interest is compounded monthly, right? So you can, I didn't mean to cross that out. So we have $15,000 being invested at 9% PA. So PA means per annum, which is per year, okay, for 3 years. So we can't use that 9% in our formula because the interest is being compounded monthly. The interest is 9% for each year. So you're not actually getting 9% every single month. You're getting 1/12 of 9%. Okay, so we plug that into our formula. So our amount will be equal to, so our P is our amount we start with, which is 15,000. Outside of 1 plus, now remember it's 9% divided by 12 because it is compounded every single month. So 9% of course as a decimal is 0.09, and we can just leave that as a fraction being over 12. You don't need to work out what 0.09 divided by 12 is, because it's just going to make a bigger decimal for you to write. So it's super easy just to write as a fraction, and it also gives you a little bit of a reminder as what you actually did to get that number. Okay, now we're told that the amount is invested for 3 years. Okay, so if you remember in our formula, I'll just come back to our formula. N is our number of time periods, not to be confused with the number of years. So it's the number of compounding periods. So when we're told that our interest is calculated monthly, the number of compounding periods means every single month for 3 years. So of course, 3 times 12 gives us 36 compounding periods. All right, so now we have our amounts we can plug into our calculator, and that comes out to be $19,629.68. Again, check that it's a reasonable answer. 15,000 going to 19,000. Yeah, it's a decent amount of growth, but it is at 9%, which is quite a very high interest rate. No one in this day and age is earning 9% on any investment. Okay, so we've got our compound interest formula, just plugging values straight in. We've got our compound interest formula where we need to adjust our rate and our time periods according to the question. And now I want to show you what happens if we know how much the investment grows to, but we need to work out something else. Okay, so we're told after 24 months, a compound interest account that pays 6% per annum has a balance of $10,940. We want to know how much money was initially invested. So this time we're asked to express our answer to the nearest dollar. Okay, so rather than A equals a principal outside of 1 plus blah, 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 okay, we don't know what P equals. That's what we're actually trying to find. All right, so we write in what we do know. We do know our amount ends up being $10,940. So we have $10,940 is equal to, now P we don't know, so P outside of 1 plus, now our interest rate is 6% per annum, and it's in there for 24 months, okay? So obviously, because our rate is expressed per annum, it's being compounded yearly, because we are not given any other information to say otherwise. So how many years are in 24 months? Well, 24 divided by 12 gives us 2 years, right? So 6% as a decimal is 0.06, all to the power of 2. So our rate and our time periods are in the same units. Okay, so rather than working this out and then trying to get P on its own, what we're going to do is we're just going to get P on its own straight away. So like any equation or problem that we need to solve where we have an unknown, we want to get it on its own. So we need to think about, well, what's happening when we have a letter outside of a bracket with nothing in between? Of course, that is being multiplied. How do we undo multiplication? We divide. So we want P on the left. You can keep P on the right, but it's nice to have P on the left, isn't it? Okay, so we're dividing by this whole amount, right? So we've got 10,940 divided by or over, same thing, 1 plus 0.06 all to the power of 2. And you can plug that straight into your calculator exactly as it looks, as long as you use the brackets appropriately and you plug it in exactly as it's written on the paper, okay? And that gives us something like 9736.56. Our question asks us to express to the nearest dollar, so of course we're going to round that up to $9,737. And I'm just gonna point out that this is what I did, to the nearest dollar, okay? Because I'm acknowledging that that's what I was asked to do. All right, so make sure that you're stepping it out really clearly. Of course, we only put one equal sign on each line. Very concise, very neat, showing what we're doing. We're not trying to jump steps and skip steps and just get our answer as quick as possible. That's not what it's all about. It's about showing understanding and showing you know how to use and apply the formula to various problems. Okay, hopefully that was really helpful for you. Anything else you want me to cover, you can comment below. If the video was helpful, give me a like and subscribe to my channel so you can get notified when I upload new videos.